For a given MIDI which contains melody with rhythm and pitches, we may karaoke it into vocal waveform with Rose Garden and Audacity. User performance can be recorded. Voice is captured while accompaniment is playing in synchronously. Transform the waveform into spectrum. Process it with key adaptation. Then it is compared against sheet music. The evaluation gives a score of the performance. Start Rose Garden for MIDI playback. Get MIDI from the net. Save it to disk. Create a directory for the work. Move the download MIDI to the working directory. Import the MIDI. Bring up Audacity for recording. The tools were installed. Go to Reference if not. Set up the earphone and microphone. Filter out tracks and just keep bass. Start recording. Start MIDI playback.
My bunny lies over the ocean. My bunny lies over the sea. Bring back my bunny to me.
Stop recording. Cut out the silence. Save the waveform. To generate the reference waveform from MIDI for artificial intelligence, use timidity. Set command path to include timidity. Make a MIDI that contains melody only. Export the reference MIDI with vocal track only. Convert it to waveform using timidity. The MIDI waveform serves as a reference for the deviation measurement. The captured voice can be evaluated using artificial intelligence. Start Python interpreter. Import librosa library. Load the capture waveform and MIDI reference waveform. Close-up look at the waveforms. For a simple 440 Hz sinusoidal wave, it can be found to have a spectral magnitude at 440 Hz by using Fourier transform. A 659 Hz wave at 659 Hz in spectrum. The combined waveform, which cannot be easily tell what frequencies. Only through Fourier transform, it has two clear components in frequency domain. Take a look at the capture waveform. It has three dominant components at 418, 637, and 214 Hz. Let's generate these three sinusoidal waves at the given frequency. And combine them into one waveform. The synthesized results waveform looks close to the captured waveform. Transform time domain waveform to spectrum in frequency domain. Shift the key for performer. Shifting musical key is the performer specific. This is the reference spectrum. Evaluation based on reference and give it a score for the performance. Analyze the sentiment of captured voice using artificial intelligence neural network. Import TensorFlow and Keras. Download voice dataset for the machine training. Extract the dataset to working directory. Load the dataset. Create model. Specify input layer and middle layers. Finish with output layer. Compile the model. Keep timer running so don't overcook my sashimi. Train the model with dataset. The model has been trained with parameter in place and ready to read. Copy a waveform for test. Test the model and observe the result. Now evaluate the captured voice by AI neural network. Speech recognition can be done on the voice as well. MoneyPy can be found at GitHub. That concludes the presentation. Hasta la vista. Adios.